All right, an overhead view of a door is shown, and we're given that the compressive force in this strut is 17 pounds. And we are asked to determine the moment that this force creates around the hinge axis back here at point O. Now, this is a short problem. The only thing that we have to do is really break this force up into some components, and we'll make a good decision on the type of components we'll use, and then we can do a scalar approach to determine the moment that each force component makes around point O. So, if we think about this force, we've got a 20-degree angle here from this dashed line, which is drawn perpendicular to the plane of the door. So this force, by the principle of transmissibility, we know we can think of acting at A. So I'm going to sketch the components of the force as if they act at point A. So I've got one component that's perpendicular to the door, and then I would have a second component that is parallel to the door. And, if we want, we could call them, like F normal and F tangential, something like that. But those two components are what we can use to take a moment. Now, for this problem, I'm actually going to take clockwise to be my positive sense of rotation here. And then the moment around O is equal to the following. Well, if I look at Fn, Fn passes by point O, or misses point O, because it travels on this line in space. So it has a perpendicular distance from O of 12 inches, and by the right-hand rule, this force would tend to create a clockwise rotation around point O, which is positive. So I have a positive 12 times Fn for his moment contribution. And then for Ft, if I look at his line of action in space, he misses point O by this distance here, and that distance is really the sum of these three dimensions. 1.5 to get me from O to the plane, 1 3/8 for the thickness of the door, and then 1 inch out here to this point where I know that Ft is applied. And it's also going to be a clockwise rotation. If I think about it, when this force goes past point O, it's going to tend to create a clockwise rotation. So that's also positive. So we have a plus 1 1/2 plus 1 3/8 plus 1 times Ft. So they're both positive. And all we need to do now is substitute. So this is 12 times Fn is 17 times the cosine of 20 degrees, and then plus 1.5 plus 1 3/8 plus 1 times Ft, and Ft is 17 times the sine of 20 degrees. And that's it. If we add this up, moment around O equals, we're obviously going to get a positive number. I have used units of pounds for the force and inches for the dimension, for the lengths. So this comes out to 214 pound-inches, and it is a clockwise sense of rotation that it creates. All right, that's it for this problem.